this question last time. So if you didn't do this last time and you find today a bit difficult, you might want to go through this question again. Okay, easy thing to do is download the notebook, rub these out, and then have another go. So here's question 2. It's not actually a very long question. It should only take you about a minute to do. So without further ado, 60 seconds, off you go. Okay, time is up. And if you're not quite sure how to do this may have taken you, you might not really got near to the end of the answer yet. But when you see how to set it up, you'll see how easy this question is. Oh no, wait a minute, I've confused this wrong. No, I think it is a 60-second question. Let's have a look. So we've got T1 here, and we've got T2 just here. And as far as Q is concerned, it also have T2. We've got P is 4.5 G, and you've got a normal reaction there, R1, and you've got a normal reaction there, R2, and you've got we've got 6G here. Now, if we resolve horizontally on P, what we get is we're going to get the mass times acceleration, the resultant force, 4.5a, will equal T1 minus T2. So the resultant, ma in this direction, will equal the T1 minus the T2. And if that's the natural thing to do, but if you resolved on Q first, because we don't get anything from that, because we know A, we don't know T1 and T2, we'll get that 6a just equals T2. If you look at Q, the only force acting on it horizontally is T2. So the resultant force is equal to T2. So therefore 6 times 2.1 equals T2. And that comes out as 12.6 newtons. And therefore T1 will equal 4.5a, which is times 2.1, plus 12.6 newtons. And add all those together and you get 22.05 newtons. Right, now question 3, if there's no questions in the class. I'm not doing the whole system, I'm resolving on each particle in turn. I just got asked why the mass is not 12. I can't see a mass of 12 anywhere anyway. Where to get the 4.5 from is the mass of this particle up here. Yeah. So initially I did that particle, which is that resultant, and the only things acting horizontally are T1 and T2, and they must combine to give me my resultant force, the ma. And then I resolved on this one here, and the only things acting on it actually is the T2, if you look, and that T2 must give you all of ma. So therefore ma must be equal to T2 because it's the only force acting, so that force must be the whole of the resultant force. Okay, good questions. Right, question 3, which I gave you not quite enough time for the last one, so we'll give you at least 2 minutes to have a go at question 3 because I think it takes a minute just to draw the picture. Okay, time is up. How are we done on that in class? We finished? This is a bit longer, this one. So therefore I will give you 4 minutes. I don't have a 4-minute timer, so I'll give you a 5-minute timer. If the class finishes early, I will get into the answer early. 1 minute to go. Okay, that's your 5 minutes. So quite a tricky little question there. So let's draw some forces on this. So let's draw the normal reaction here, R1, and we can draw in the mass times the G, 24G, and we've got 15G here, and we can call that R2. We're not really going to need the normal reactions in here. We'll assume it's accelerating. Okay, because we're not told it's in equilibrium, so we need to assume it's accelerating. And we'll put a tension in here and a tension in here. So if we resolve on the 24 kg first, we've got 15 kg. We're not sure what to do here. So we're going to resolve on the 24 kg and we'll resolve in that direction. So we got MA, so it's 24A will equal F here minus the tension minus 80. Okay, so we can also get from this one, let's resolve on this one, resolve on the 15 kg in the same direction. So we're going to get 15A will equal T minus 50. And overall on the system, okay, 15A, we've got the T acting that way, we've got the 50 acting that way. Overall on the system, okay, we've got 39A will equal the force driving forwards. Now we don't need, when we're doing the whole system, we don't look at internal forces, tension, we don't look at that, we just look at the external forces. So we've got minus the 80 minus the 50. So we can simplify that down to, let's get some more space in for our question. So we can simplify that down to 39A will equal F minus 130. So let's rearrange that. We get the friction is equal to 39A plus 130. Let's factorize that out. That's 13 times 3A plus 10. Now, if we rearrange this one here, we can see that T will equal 15A minus 50, plus 50 even. And if we take out a factor of 5A, we can see that T equals 5 open brackets 3A plus 10. Now we know that T must be less than or equal to 120, otherwise it's going to break. So we know that T is less than or equal to 120, otherwise it's going to break. So therefore this thing here, 5 is less than or equal to, sorry, not 5. 5 open brackets 3A plus 10 is less than or equal to 120. So we can see that that is less than or equal to 120. So therefore divide both sides by 5. We get 3A plus 10 will be less than or equal to 24. And what we notice is we've got 3A plus 10 here, and we've got 3A plus 10 there. I'll put the bracket back in. So therefore the friction must be less than or equal to 13 times 24. So not friction, the driving force. So we substitute into equation 3, I think that would be. That was equation 1, that was equation 2, that's equation 3. Substitute that into equation 3, and we get F is going to be less than or equal to 13 times 24, which comes out as 312 newtons. All right, a bit more space, the second half of the question. So part B. So what was part B? The string breaks and the boxes are moving at a speed of 2.4 meters per second. Assuming the boxes do not collide, how long does it take for the second box to stop? Let's write that down. So the U is equal to 2.4 meters per second. Now what we've got to do is we've got to work out the acceleration of the second box at this moment in time. So it's still got the tension acting here. We've got the acceleration going that way. So no, we haven't. We don't have tension and we don't have acceleration. I'm looking at the wrong part of my answer. So what we got here, we've got actually all we've got is just the resistance force, which was 50 newtons. And we've got the mass 15g, and you got your normal reaction here. So therefore the MA will equal the 50 newtons there. So we've got 15A equals 50 newtons. So A will equal 50 over 15. And that comes out to be 10 over 3. And it's going to be a negative acceleration. It's going to be this way. If we're resolving that way, it's going to be that way. So you need to know that that's going to be a negative acceleration. So if we actually resolve that direction, then it makes it all nice, gives us our negative acceleration that we need, okay, for it slowing down. And then we can just use SUVAT to help us. We know that T equals V minus U over A. We know that V is 0, so T will equal 2 minus 2.4 divided by minus 10 over 3. And that comes out to be 0.72 seconds. So first half, quite a tricky question. Basically, as I said earlier, if you just actually write out all your equations, and you might spot something that will allow you to be able to do it. A tricky little bit of algebra to save you some time. You don't actually have to be able to do this algebra to save you some time, but it does help. You could have just done, we could have got this in terms of A and then substitute back into A. But seeing there's a 3A plus 10 as a factor of both, it saved a little bit of time. Didn't have to do that. We could have taken away 10, we could have divided by 3, we could have substituted that in as well. So if you didn't like that little bit of factorization, finding A itself isn't a bad way of doing it, and then substituting it in and then getting your 312 would also work as well. Right, where are we up to? Okay, nearing the end of the stream. I thought we'll leave out question 5 for now. maybe come to another lesson. We're going to jump onto some pulley questions and some nice easy pulley questions after that one, just to take it down a bit. So let's just change the view on this and zoom in a bit. Not that much. Okay, so quite a straightforward question. Let me just look at my model answer. Yeah, this one is a 1 minute. I think I was confusing this starting question with my other starting question. This is definitely a 60-second starter. Okay, so if you're not sure about these, you're going to be kicking yourself when you see the answer. So we've got tension acting up, we've got 76G acting down, we've got tension acting that way, and then they've got that way as far as the pulley's concerned, but that way as far as a man's concerned, and then he's going to pulling with a force. Is it a man? It is a man. Pulling a force that way. So let's just resolve on here. So resolve on this. Resolve. It seems like overkill, but it's really important you set up the model simply to start with, especially on these simple ones, and build them up. So we resolve on the 76 kg, and we'll make that the positive direction. It's in equilibrium, I think. Yep. So therefore T will equal 76G. And then we can resolve in this direction on the man, on the end of the rope. And we can see the man's got a force, at this point, he's got a force pulling that way and the tension's pulling that way. So F will equal T. So the man must be pulling with a force of 76 G newtons. And it really is that easy. Because F equals T, T equals 76 G. Right, bearing that in mind and make sure you set it up simply, you're sure you'll get this one right. And this one, I'll give you 2 minutes because it is just a little bit longer, but probably you can knock it off in 60 anyway. we'll stop there. So let's draw the force diagram, and we've got 5G acting down this way, we've got tension acting up that way, we've got 7G acting this way, we've got tension acting up that way. So we're going to assume that it's going to accelerate in this direction, in the direction of the heavier mass. So let's resolve vertically on the 5 kilogram to start with. And we get the mass, the resultant force, the mass times the acceleration, 5a, will equal the forces in the same direction, t, minus the forces in the opposite direction, 5g. And then let's resolve in the other direction on the 7 kg. And we'll get 7a equals the 7g minus a t. That the 7g is going the same direction as the acceleration, tension's in the opposite direction. So therefore we've got equation 1 and we've got equation 2. Let's add those two equations together. So 5a plus 7a is 12a. T minus t is 0. Minus 5g plus 7g is 2g. A equals 2g over 12 meters per second squared. I think that comes out, if you've done it in decimals, 1.63 recurring meters per second squared. So we substitute that answer, 1.63. Let's put it into 1, shall we? So we get 5 times 2g over 12 equals t minus 5g. So t will equal, that's going to be 10g over 12 minus 5g. So, which gives us 5g over 6 minus 5g. So these both go over 6. That'll be, no, it's not a minus 5g, so I need to add. Take that to the other side, add. So that will give me over 6, that will give me 30g over 6 plus 5g over 6, that will give me 35g over 6 as my answer. And if we work that out, just grab a calculator. 35 times 9.8 divided by 6 gives me 57.16. Okay, how are we doing? We've reached the 35-minute mark on the stream. I'll try and keep these under 40 minutes. So we'll stop there, okay, and we'll just finish off the Pulleys question tomorrow. We might and maybe do the last of some other questions we've not done in the other sections, just to do for a bit of revision.